Hi, welcome back. It's Paul Pujol with Senko Mechanical, of course working with Greenway Solutions. And we're part two of our blower door uh, calculations. And this is part of one component of an energy audit. And we're going to look now at converting that number we got from the blower door in the first segment. And we're going to calculate the base the base building airflow that you should have to meet the minimum standards of airflow in a building to give it its basic ventilation needs. And we'll look at the difference and then see what we could do with air sealing and how much money we could save. So let's get started with the calculations. Your airflow building air tightness standard is the volume of the building times 0.35. They do 0.35 air changes per hour. And we're going to divide that by 60 minutes every hour and get a CFM. So the volume of this house it's a 3,300 square foot house. So we take 3,300 square feet and we take the times 8 is the ceiling height, and that'll give us the volume. So we take 3,300 times 8. So this house is equals 26,400 for volume times 0.35 is 9240, 9,240, and then we divide that by 60, and we need, that's equal to 154, so we need 154 CFM ventilation in this house. Okay? Now, we're going to figure out what that would be in a blower door number. There's a number called an N factor, and that's the factor that we multiply this by to figure out what the blower door number would be at minus 50 pascals. So the N factor for this area in a story-and-a-half building like this is 16.8. So we multiply 16.8 times 154. And that gives us 2,587 CFM. We subtract that from the 4,900, and we come up with 2,312 CFM, and that's the number that we could seal. We could seal the air leakage down that much and still maintain our minimum that we want to maintain for basic ventilation in a house. Now, if we want to see how big that leak is in square inches, we could take the 2,312. Actually, let's take the big number, the 4,900, and get the total size. We take 4,900 and divide it by 7.56. And that gives us 648 square inches. Square inches of leakage. And if you divided that by 144, that would give you the square leakage in square, or the leakage in square feet. So it's equivalent to 4.5 square feet of leakage area. That's roughly a little over a 2 foot by 2 foot hole. Now that's all the little cracks and crevices combined. Now, if we had 2,312 CFM, another calculation we can do is we can find out how much that's costing us to have that excess air leaking out of the house. So we take 2,312 and we're going to divide that by 16.8. So let's do that. 2,312 divided by 16.8 equals 137.6. We're going to multiply that times 60. We're going to multiply that times 0.018. That's how many BTUs are in a cubic feet of air. And multiply that times 24 hours in a day. And we come up with 3 million. Oh, and then we want to multiply that, times the degree days. In this area, in the Delaware County, Chester County area, we have 5,395 degree days. So we come up with 19,244,425 BTUs of heat that we're losing. Okay? So now, depending on what you pay for a BTU of heat, that's going to determine what you would save. Now, let's say you had natural gas. So natural gas is sold by the 100,000 BTUs, which is a therm. So we'll divide that number divided by 100,000. 19,244. 19,244,425 divided by 100,000 is 192.4 therms. Now, assuming that you had let's say you had a very efficient furnace. Let's say it was 100% efficient, no furnaces. But if you had to buy 192 therms at, let's say, $1.40 a therm, you would be talking about $269 a year is what that excess leak is costing you. Now, let's say you could fix that leakage, and it would cost you $1,000 to fix that leak, to go up and seal all the cracks and crevices that are causing that leakage. So if you paid $1,000 to seal that, we could take $1,000 divided by 269, and it would take 3.71 years to get your payback. And that'd be a very good investment. And that's not calculating that fuel would increase. That's calculating also, we're basing this on natural gas, which is probably the least expensive way to heat a house. If you had straight electric or oil or propane, it would be much more costly, so the energy savings would be much greater. So we recommend that everybody have a blower door test and find out if you have excessive leakage, and then correct that leakage and save a lot of energy. There are also some other things that we're going to have some more videos here that we're going to present. We're going to talk about furnace efficiencies and what that could save you. Some safety issues regarding the venting of furnaces and natural gas appliances, fossil fuel appliances. We'll talk about that at a later video. Once again, thanks for joining us here. Once again, Paul with Senko Mechanical and Greenway Solutions. Thanks.